Welcome to Drift Education. We already know what is Euclid division lemma. Let's start with the problems. As we discussed, there are two types of questions. Type 1, HCF and Grouping. Suppose we have a question which says, a sweet seller has 420 Kaju burfis and 130 Badam burfis. She wants to stack them in such a way that each stack has the same number and they take up the least area of the tray. What is the number of that can be placed in each stack for this purpose? Here, the sweet seller wants to group Kaju burfi and Badam burfi. But the condition is in one group or one stack, the number of Kaju burfi is equal to the number of Badam burfi and it must take least space. How about taking the HCF? Why? You must be wondering. Because what we need is equal number of burfis, means the number of burfis of each kind should be common. Let's find the highest common number, as we will have lesser groups and then it will take least space in tray. In short, we have to find HCF of 420 Kaju burfi and 130 Badam burfi. Now, the steps are 1. Break down greater number in Euclid division form by long division method. That is, 420 equals to 130 multiplied by 3 plus 30. Second step, divide it further until remainder becomes 0. That is, 130 equals to 30 into 4 plus 10 and 30 equals to 10 into 3 plus 0. Third, the HCF of number is second last remainder of those two numbers. Here we can see the second last remainder is 10. Fourth step, hence the HCF is 10 for 420 and 130. So the lady needs to have 10 Kaju burfi and 10 Badam burfi in each stack or group. Now about the other type of question we can solve. It is more of theoretical based. Let's see how to solve them. Type 2. Suppose we have to show that any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. Here are the steps. Step 1. Let's take a as the positive integer. Step 2. Now we will take b equals to 4, and as per Euclid division lemma, the value of r is less than b, that is 0 less than equals to r less than 4. Note, why we took b equals to 4? Explanation. Since in question the numbers are in the form of 4q plus 1, so comparing it with Euclid's theorem, we can take b equals to 4. For example, if it was 5q plus 3, we will take b equals to 5. Okay, now coming back to the steps. Step 3. So we can write a equals to 4q, which is case 1, a equals to 4q plus 1, which is case 2, a equals to 4q plus 2, which is case 3, a equals to 4q plus 3, which is case 4, according to Euclid division theorem. Here we can see case 1 is divisible by 2 and it gives 2q after division. Case 3 is divisible by 2 and it gives 2q plus 1 after division, where as in case 2 and case 4, a is not divisible by 2, so we can say they are odd positive integers. Hence, we prove any positive integer a equals to 4q plus 1 and a equals to 4q plus 3 is odd positive integer. I hope now we can tackle this kind of question. As a challenge, try solving exercises and don't forget to ask your doubts. See you in the next class.